All right, so this is the second lesson for significance tests. Okay, so just a few important notes, and then we're going to go through and practice one. So, important notes. So, first thing is we're looking for a p-value. So, when we did a normal distribution, we always went in here and said, okay, we've got this area, and we called this area p. Was our proportion, our percentage, and we just called it p. Okay, but now we have something called a p-value, and our p-value is our conditional probability. And here's the important thing. This assumes that the null hypothesis is always true. So remember, the null hypothesis is H naught, H sub 0. So assuming that this is true, the p-value measures how likely it is to get evidence for your alternative hypothesis. So we want to know how extreme or more extreme in the direction of the alternative, and is that by chance alone? Okay, so the first thing that you have to do is you have to name the test, either by writing down the test name. So right now what we're going to do is a one proportion z-test, or by writing down the generic formula. So our generic formula here is going to be z. Now, don't get confused with confidence interval. With our confidence interval, it was z star, but now we're talking about just z. And our formula here, if you remember just our normal standardized formula, it's going to be x minus mu over standard deviation. Well, this formula of z here for our one proportion z-test is not on your formula sheet. Okay, and so you just kind of have to remember what this is. So put it back in context of what our standard formula is. So this is our sample minus our statistic minus our population mean over our population statistic. Well, here what we're going to have is we're going to have our sample proportion minus p naught. And p naught, remember, is when we say our null hypothesis, we say p is p naught. And this is over the square root of p naught 1 minus p naught all over n. So here's our formula, and this p naught is our proportion, and this proportion here is our claim. So what are they saying is happening? What is true? Okay, so for a hypothesis test, so a hypothesis test, this is the same as our significance test. So if you see this, don't get jammed up that you don't know what a hypothesis test is. This is our significance test. This is what we're doing right now. So when we check for independence here, we're going to check n times p naught, and we want this value to be greater than or equal to 10, and then n times 1 minus p naught. So when we did this with confidence intervals, we were checking with our statistic, our p hat, but now we're going to check this with our p naught. Okay, so it's important to know which parameter you're putting in here. Okay, and for confidence intervals, this is what I want to say. So for hypothesis tests, we're testing p naught. For confidence intervals, I'm going to change this up here. So for confidence intervals, we're doing n times p hat. Right? And we want this value to be greater than or equal to 10. So make sure you understand when you're using p naught and when you're using p hat. Okay? When there is not convincing evidence to reject our null hypothesis, it does not mean there is evidence that it's true or that it's false. So we never say except. So if we reject, we don't say we accept H sub A. We just say we reject. Okay, so when we're conducting our significance test, we're going to set this up exactly like we did our confidence intervals. So we have our 4 parts. So part 1 is our communicate part. And this is where we define our p-value, we'll identify our hypothesis that you're testing, and your significance level. So we'll have our hypothesis, we'll have our alternative hypothesis, we'll have our significance level. You're probably going to have your p hat, and you're probably going to have your p naught. So you'll have all of this information that you're going to communicate. Okay. Next is going to be our conditions. These aren't any different than what we've done before. So random conditions, random sample, random assignment. Independence, we're checking our 10% condition. And then our normal large counts, again, we're checking here for p naught instead of p hat. Next, we have our calculate. And we want to identify the inference that you're performing. So in this case, it's going to be a one prop z-test. And our z-statistic, I wrote this up there, but let me write it again where we have more space. So it's p hat minus p naught over the square root of p naught 1 minus p naught over n. And remember, p naught is our claimed statistic. Okay, so what it says here is we're going to find our p-value by generating the statistic and looking for the value being extreme or more extreme. All this is saying is that we're going to run normal CDF, so you're going to have some sort of normal curve, and our alternative hypothesis is going to be less than, which is going to be down here, or greater than, which is going to be up here, or it's going to be unequal to. And if it's unequal, then we have two parts. We have to count this part and this part. So go back and look at the last homework, the homework that was for 6C, and I go through all of this calculations for P, all right? And then finally, our conclusion. Now, our conclusion is really important. I had this in a nice table last time. This is not in a nice table, but what you need to do is just memorize this conclusion, just like we memorized our conclusion for confidence interval and confidence level. So here's what this looks like. Because our p-value of whatever our value is, so let's just say that we calculate this and we get a p-value. And remember, p-value is the same as p. So this was our proportion. Now we say p-value because we've got this grouping of values in here that come from our test. So let's just say that our p-value, just as an example, was 0.20 and our significance level was 0.15. So we would read this as, because our p-value of 0.2 is bigger than our significance level of 0.15, then we failed to reject our null hypothesis, or reject, depending on whatever it has, and then we don't, or do, have convincing evidence that the population proportion of, and then of course context. This, you've got to know. All right? It's just like the other one. You're going to want to know that. All right, let's practice. So here we are. We're going to do the whole thing. So example. So we have, it says, Alan reads a report that says 80% of U.S. high school students have a computer at home. He believes the proportion to be smaller than 0.8 at our school. Alan chooses an SRS of 60 students and records whether they have a computer at home. He wants to test this at the 5% significance level in his sample. 41 of the students have a computer. Is this evidence that the proportion of students who have a computer at home at our school is less than the national proportion? So, first thing we're going to do is communicate. So here's what we know. P is going to be the proportion of students with a computer at home. All right, so first we have to identify our null hypothesis. So our null hypothesis is the claim, and the claim is right here, 80%. So what we say is that P equals 0.80. Now we have to identify our alternative hypothesis. So Alan believes the proportion is smaller than 0.8. So our alternative is that P is less than 0.80. All right, so let's write down everything else that we know. Alan chooses an SRS of 60. So N is going to be 60 students. He wants a significance level of 5%. So alpha is 0.05. In this sample, he had 41 students. So I can calculate my p-hat. My p-hat is going to be 41 over 60. And when I plug that in my computer, or in my calculator, oops, I can't find my calculator. Hold on. I know I have it around here. 0.6833. Okay, so next thing that we're going to do is we're going to check our conditions. So first thing, is this an SRS? And it tells us right here we have an SRS of 60. So we're good. Okay, so next we're going to check our independence. So independence, 60 is going to be less than or equal to 10% of all high school students. So yes, we know that that's true. And now we need to go and see, okay, is this normal? So remember, because this is a significance test, we're going to test P naught. We're using 80.8. We're not using P hat. So what I have here is that we have 60 students times 0.8, and this has to be greater than or equal to 10, and then 60 students times 0.2, and this has to be greater than or equal to 10. So we would have 48, so this works, and 12, which this works. Okay, so our conditions are all met. So now we're going to go in here and we're going to do our calc. So first thing that I'm going to do is I'm going to list my test. I'm going to run a one prop z-test, and I want to calculate my z. Now again, this formula is not on the formula sheet. It's p hat minus p naught over p naught 1 minus p naught over n. Well, I have everything that I need up here. So what this looks like is 0.683 minus 0.8 over 0.8 times 0.2. All of this is going to be divided by 60. And when you run this, you get negative 2.266. Okay, so what is this saying? This is saying that in my normal curve, down here at negative 2.266, my alternative hypothesis says that P is less than 0.8. So because this is less, I want this value, which is going to be less than. Okay, so when I run normal CDF, my lower bound is negative infinity, my upper bound is negative 2.266. And now what this gives me is a p-value, and this is super important. It's a p-value of 0.0116. Now, previously, what we would say is p equals, but because we're running this, we have to say p-value. Okay, now this is the value that we're looking for. So now we can put this all together in our conclusion. So what we want to say in our conclusion is because our p-value of 0.0166 or 0.0116 is less than our significance level of 0.05. Now I'm just going to put this in an inequality. 0.0116 is going to be less than 0.05. We reject the null hypothesis. And if you remember, what we say here is if the p is low, the null must go. So if the p is low, the null must go. So that means we reject the null hypothesis. Okay. Now, if we reject, this means we have convincing evidence that the proportion of students with a computer at home is less than 80%. Kind of ran out of room there. Okay, so this is the whole thing. So all four things. So when we're doing a confidence interval or we're doing a significance test, you have to have all four conditions. You have to have communicate, conditions, calculate, conclusions. Okay, now our calculator has this ability to do a one prop z-test. So with this example that we have up here, we know our p naught, and our p naught is 0.8. We have our x, which was 41. So x, remember, 41 of the students have a computer at home. Our sample size is 60. And because we say this is less than, we're going to use, it's going to be less than our proportion. Only because we say up here that our alternative hypothesis is less than. So we continue to use less than. Okay, and you go in and do one prop z-test, and we end up with a value, a p-value of 0.0119. So it's a little off of mine, 0.0116, but remember, I was rounding mine. Okay, so we rounded the z-score, and the calculator is not going to round. It's going to just keep on going like you see here with p-hat. Okay, so interpret our p-value. All right, so what is it that we just calculated? We have our conclusion, but that's different than our p-value. So if the true proportion of students with a computer at home is 80%. So we state here, if the true proportion of students with a computer at home is 80%, this is my null hypothesis. This is H sub 0. Then the probability, our sample has 41 or less. Now it's 41 or less because that's what my alternative hypothesis was, out of 60. Now remember, when we did confidence intervals, we had to talk about our sample size, and that's what this is. The probability our sample has 41 or less out of 60 with a computer at home is 0.0116. Okay, so that's what that's saying. That's saying assuming our null hypothesis is true, and we talk about our sample size, because remember, we have to have a sample that models what we did in our test. That makes this true. Okay, the next page that you have in your notes is another example that came from College Board that talks about does the color green, do people identify the color green with things being more natural? So I want you to practice this. I've got the notes posted on Schoology, so you can go in and look at this after you set it up. Let me give you just a couple of reminders here. If you don't know your sample statistic, if you don't know p-hat, remember we always use the worst case scenario, so we would use 0.5. Now in this case, because of this sample statistic, what happens is that it says is that we can either pick the color green or the color white out of a cup. So in this case, what we're looking for here is not this. We're going to say that P naught is 50%, because this is, you have the option of picking a green cup or you're picking a white cup. So we're saying that our initial probability is going to be 0.5, 50%. So this is a little confusing when you read this, so I wanted to give you this hint before you try it on your own.